Okay, now this I expected. Because usually at the end of the semester, when we're going to take our test after we've done chapters 8, 9, 10, and 12, we've gotten so used to the common critical values, and we forget how to find critical values and p-values in general. So when we're not, let me go ahead and go to one of our old slides. I'm sorry, this is the Triola Statistics Review, and this is one of the approved test pages, for the notes pages. And we get so used to these common critical values, like when the confidence level is 90%, in other words, when the significance level is 10%, when the confidence level is 95%, in other words, when the significance level is 5%, or maybe more often the 1% significance level. And so on the normal distribution, the z-scores, we're really quick at just pulling out these values. We've probably even memorized a few of them. So if we're doing hypothesis tests, we're doing left or right tail tests, we're probably used to those as well. Okay, but we sometimes forget that to find a critical value, in other words, the z sub alpha over 2, and this was from chapter 7, but it doesn't matter really where it was. We're still going to, because it's has the notation here, we're still going to split the tail. So this could be thought of as like a confidence interval, chapter 7, where it actually first appeared, or like when you are finding the critical values for chapter 8, when you're doing hypothesis tests, and it's a two-tailed test. So if the level of significance is 4%, in other words, the confidence level is 96%, then we take this number, we split it in half, and then we can look on the chart, or we can use several other technologies. Okay, so I'm going to go ahead and go with the calculator first. You know what? I will go with, I'm sorry, I'm so fickle, but I will go with the chart first. So I'm going to, this one's blurry. I'm going to go to our approved foldout. I'm on the z distributions, and I'm going to look up, splitting that 4% into half, I'm going to look up point 0.02. I'm going to look up 2%. So, and I might not get all the way there, but I'm going to get close. So this one right here is 3 10,000ths off, and this one right here is only 2 10,000ths off. So I'm going to use this corresponding score. So this is negative 2.5. Now that's because the area on these on this table always come from the left. It's the left area. Now similarly, that would be like putting in the calculator the command for the normal distribution. Let me get my calculator to work. Alright, so you can get there by hitting second vars and then choosing inverse norm. This is what we choose if we know the area score, the body inside, and we want to find out what the cutoff score is, the critical value is on the horizontal scale. So I'm going to put in 0.02. Now actually, if I'm really, I don't know, concerned or lazy, I can put in the 4% and put divided by 2. There is alpha over 2 right there. And this will basically look into the body, look into the area score, and pull out the corresponding z-score. Now, what do I get? I get that same negative 2.05, right? Isn't that where I was at? or where I was, negative 2.05. But I need to remember that this is not the critical value that I'm looking for, because if I was looking for the negative critical value, there would have been a negative symbol right in front there. There would have been a negative symbol right there. But I'm assuming that they were using this in their error estimation, and I will go to that. In fact, I will go to that by going to the review card. So when we did confidence intervals, remember how we did these error estimations? And this is always with the positive score, but then we would add and subtract. So here's where we first, let me show you where we first came up with confidence intervals, because this is 2 sample. That was later. Here is 1 sample. And we would use the positive one, and then since now we can think of the magnitude of the error, we can subtract and add it from our best point estimate. If our best point estimate was p hat, we would add and subtract. If it was x bar, we'd add and subtract. So it's the same basic idea. Okay, so I'm going to put in 2.05, and I'll hit submit. It's the only one I answered, so it better be right, number 43. But what I like is that if we would have used StatCrunch, we could have kind of visualized this process more. We can go stat, use one of their calculators, specifically the normal calculator, and here we'll let the mean be 0 and the standard deviation be 1. And why? Because those are the stipulations for a standard normal distribution. How do we know it's standard? Because we're looking for the z-score. Now, on the picture it has an x score, or an x number, because they're labeling it really generically, since these means and standard deviations can be changed. Okay, we want to pin in 2% on the top and the bottom, because we're going to be splitting that 4%. So I'm computing it on the bottom here, and it gives me the negative 2.05. But if I wanted to pin 2% on the top, that could have been done if I would have just turned the curve around, turned the shading around, right? So it would be up here. Unfortunately, the calculator and the table can't do this. This is why I like StatCrunch so much. It's a nice feature. First of all, it's giving you the graph right in front of you. It's showing you all the key points. But what you can do in the calculator and what you can do on the table is you can look up area from the left, which is all it does on our table, and just make sure that you have the corresponding cutoff point. So since I said earlier that this alpha is 4%, means that the confidence level is 96%, then what we can do is we can go the 96% in the center that we want and throw on half of alpha, which is 2%, over in the front. In other words, we can go 98% this way and we'll find that same spot. So here's what I'm going to do. In the table, I'm going to look up 98% left area, and it's going to give me that 2.05. So it's just off by a sign, but it is a little different concept. So here I go into the body, and I want to look up the top 2%. In other words, where is 98%? And I'm not even sure how blurry or focused this is coming in on your video, but here I've got, I'm off by 3 10,000ths there, and I'm off by only 2 10,000ths on this number. So I'm going to go ahead and go with this number. That's area of basically 98%. And look, I'm at the corresponding z-score of 2.0. Hopefully you can see my cursor, if it's not too blurry, 5. 2.05. Hope that's not too blurry. And if I use the calculator, same function, inverse vars, or sorry, a second vars, I mean, inverse norm. And let's go 98% left area. And that's what it does for the, remember that we do left area for the standard distribution, but we do right area for the chi-square. So just keep in mind, we try to make the conventions a little bit unique to the distributions, so that way we don't mix distributions up. It's intentional. We're not trying to make your life more difficult. For example, you know, this cutoff score, this z-score that we're seeing here, it goes on, you know, 2.053 whatever, but for z-scores we always round it off to 2, and for t-scores we round it off to 3. So we set up these conventions to make considering the distributions a little bit more unique. Makes it feel like, I don't know, that you know that you're in the right place. Okay, anyway, 3 different ways: table, calculator, and StatCrunch. My favorite here is StatCrunch. Very easily to manipulate. It's going to be available to you next to each problem, and it shows the picture.